Hi, this is Paul. I'm the developer of Hyperion Synth. I want to talk about some of the latest features in the user interface of Hyperion and talk a little bit more about some of the nodes in more depth, especially the oscillators and filters, and just cover some of the things that I haven't covered in the previous tutorial videos. One of the latest additions to Hyperion UI is the large patch browser mode, which features multiple columns, including the folder selection column and the patch filters area, which lets you select filters by clicking on toggle buttons, and those affect the patch list itself. For example, we could filter by synth sounds and by warm category. And another new feature is the favoriting option with the favorites filter. Here you can see favorites being turned on and off. And another new feature is filtering by substrings for the author and the patch name. So for example, we could search for a particular author name just with part of the name and find those patches, and the same with the patch name. To mark a patch as a favorite, simply click on the heart icon at the bottom of the patch list, and you can click again to unmark it. Also, a new feature in the latest version of Hyperion is the ability to delete patches directly from the list with the trash can button. Recently, there have been a number of improvements to the way cable highlighting works. Now, when you click on a node, cables are highlighted in both directions, both inputs and outputs. And you can click on the individual output or input pins, and you will see the highlighted cables that are connected to those pins. Another feature that was added in a recent release is the automatic highlighting of target pins. So when you start a cable from an input or an output, the associated available target pins will get slightly brighter, helping you to see where you can actually connect a cable to. Also recently added were buffer nodes. These are nodes that let you drag a cable from a long way away and then simply distribute it to another location in the graph just for convenience purposes. And so there's one of these for control data, and there's also one of these for audio nodes and FX bus nodes. It's pretty convenient when you want to connect up multiple target nodes to a particular output, and then rather than having to drag a cable from each node to the source, you can just have a single cable going to one of the buffer nodes, and it just makes the graph a little bit cleaner in some cases. You'll notice that the cables for the buffer nodes are slightly darker than the normal cables, and this is just to make things a little bit cleaner on the graph as well. Another new feature that was added in a recent build is the node info button directly on the node edit panels. It's a shortcut to get to the node info, which you can also get to by clicking on the node itself, but it's kind of convenient if you want to just quickly flip between different node information. I recently added some touch-oriented nodes, and I'm just going to show those now. Those are the vector data mixer, which lets you mix up to 4 data sources between A, B, C, and D. You can modulate the position of the dot with the X and Y inputs, and you can also move that around by dragging the mouse. The same for the audio. There's an audio vector mixer for mixing up to 4 different voice sources. And we have a similar node which is dedicated to effects bus mixing, so you can mix up to 4 different audio sources on the effects bus. There's also a touch-oriented data mixer which lets you mix up to 4 sources of data, and also you can control the levels with the level input pins. And finally, the XY pad node has two modes. It has a 9 pad trigger mode, and if you open up the edit panel for that XY pad node, you can turn off the trigger pads and just have it as a plain XY pad. So let's take a look at how that works with some data viewing. Let's take a look at the value from the trigger output, and you'll see that as you move your mouse or you tap on the appropriate pad, the output level will be set to 1, which could be used to trigger samples, for example. But you'll notice that on the XY pad, without the trigger pads enabled, you don't get a trigger output. But if we take a look at the values coming out of the X and Y outputs, you'll see how those are modulated by moving the touch position in the XY pad. Each of these new touch-oriented nodes have a smoothing parameter that lets you set the amount of averaging for the touch position. So if you want to get smooth data output for the X and Y values, you can turn up the smoothing rate, which could be quite handy if you're using an external MIDI controller to modulate the X and Y inputs, for example. Or generally, it's kind of useful to filter out some of the jitter associated with using touch inputs anyways. And you can see this works for the vector mixers, and it also works for the touchpad in the trigger mode as well. A new node that was added recently, which complements the XY pad, is the 9 notes trigger node. It's got 9 inputs, and that matches the 9 triggers on the XY trigger pad. And so you can use this node to set different notes or frequencies to then be used to trigger different notes, maybe on the sample playback node or an oscillator. And you can use the MIDI note learn function within the node to set the notes directly with your keyboard. If you set the checkbox for output in Hertz, then those MIDI notes will be converted to a frequency value in Hertz, which could be used to directly drive an oscillator, for example. So here you can see an example of triggering some of the pads, and you'll see the frequency is being output as a Hertz value. Let's take a look at a basic patch using one of the init patches. This is a basic stereo oscillator with a sine wave currently selected. And we're just going to disable the filter so we can concentrate on the oscillator for the moment. And you can see there are multiple wave shapes selectable, classic waveforms, as well as a few less classic ones. The poly waveforms are named poly because they are polynomial functions. The shape parameter on the oscillator will affect each of the wave types in a different way. Some of them will be wave folded and some of them will have pulse width modulation applied depending on the oscillator wave shape you select. Another new feature that was added in a recent release is the oscillator sync function. This basically creates a virtual oscillator which is then being controlled by the shape parameter. So as you turn up the shape, the virtual oscillator frequency goes up, and then the main oscillator and any unison detuned copies will get synchronized to that virtual oscillator. So their phases will be reset based on the virtual oscillator. Here we're adding an extra pair of unison oscillators by turning the unison value to 1, and you can hear now that the detuned copies are spread in the stereo spectrum. And if you turn the detune parameter up to nearly its limit, you'll hear some additional semitone offsets come into play. The unison detune mode also works with oscillator sync. Every unison detuned copy is also being synchronized to the virtual oscillator in this os sync mode. If you enable the exponential detunes checkbox, the detuned copies of the main oscillator will get spread exponentially across the stereo spectrum rather than linearly, which can produce a slightly fatter sound. Let's take a look now at the trigger input pin on the oscillator and the random parameter. So when you connect the trigger pin to the oscillator, the phase of the oscillator, the main oscillator and its unison copies will get reset to 0 every time you hit a note. And when you've got a small amount of detune, you can hear those unison copies gradually going out of tune with each other, because they start at the same phase but gradually drift apart. And you can hear this the more we turn up the detune amount. This can be quite a nice effect to hear, but in some cases you might want to randomize the start phases of the unison detune copies, and so you can control the amount of randomization with the rand parameter. And if you don't have a trigger input connected, then the phases of all the oscillators are randomized by default anyways. The balance control lets you balance between the main oscillator and the unison detuned copies. So here you can hear more of the detuned copies as we turn it up and then back down to the main oscillator. For the noise type oscillator, you can see that some of the controls are grayed out. That's because this is not a pitched oscillator, so those controls are not relevant. And we have a sample and hold oscillator, which is actually like a tuned noise, where you can actually pitch it up and down, but again, there's no unison mode for this oscillator. Let's take a look at the wave sequence oscillator. The wave sequence oscillator is similar to the stereo oscillator, except that instead of a single waveform, you can select different wave shapes for different parts of the table. You can have up to 32 steps of waveform configuration, where you can select and change all of the parameters that you can see between the two blue lines. The group edit checkbox lets you set up the parameters for multiple steps all at the same time. This is convenient as a starting point so that you don't have to edit every single step. And once you're happy with the basic selection, you can then turn group edit off and pick individual steps, either directly with the step control or by moving the start position slider. As you move the start position slider, the oscillator will fade between the different oscillator configurations for each step. Turning off group edit then lets you select different steps in the wave sequence and edit the individual parameters for each of those steps. So for here, for example, we're changing the wave shape on step number 2 and increasing the wave folding amount, changing some of the unison parameters, edit the step 3, pick a different wave shape. And you can see that as we sweep the start position, we crossfade between each of the wavetable steps. Let's add a little bit of reverb just to make it interesting. Now typically you would want to modulate the position in the wavetable with some other kind of modulation source, not the mouse. So you can pick a start position in the table. It doesn't have to be 0, but it often is. And you could modulate that start position with, for example, an ADSR. So we're going to connect the trigger pin so that we can trigger the envelope, and connect the start position input pin to the envelope output level pin. And to get the full sweep of the table, we'll need to set the level to 1. And here we've added a slow attack and decay. And if we make sure the start position is at 0, you can see how the position is being swept across the table. You can see the animated lighter color sweeping across the table on the slider, and that gives you a good indication of where you're at in the table currently. Any of those modulation animations that you see on the sliders or knobs are for the last triggered note. Let's take a look at the filter now. Turning down the reverb so we can hear the effect of the filter a bit more clearly. A classic way to modulate filters is using an envelope. So here we're going to edit our ADSR number 2, turning down the sustain level so the filter goes back to 0, and increasing the attack and decay times just so we can hear a little bit more clearly that sweep. And just for example, let's add an LFO to also sweep the wave sequence. That's another classic way to modulate wavetables. To sweep the table, we probably want to set the LFO to become a unipolar, since the table position starts at 0. And you can see in the mod sources how both of the inputs are being added together. So we can control the amount of modulation from each modulation source independently. And let's just take a look at playing with some of the parameters in the filter. The cutoff and resonance are pretty self-explanatory. Here you can see how the cutoff is also being modulated by the envelope ADSR2. We can also use external MIDI controller or the macro knobs to modulate the filter. And you can control the amount of smoothing by changing the smooth value in the macros control panel. There's multiple filter types. MG is for Moog emulation filters. OB for Oberheim. These are self-resonating filters if you turn the resonance high enough. We've also got a Salon key low pass, a high pass filter, band pass, a biquad bandpass, and a biquad notch. And finally, there's a variation on a Moog style filter, which is a bandpass configuration. This one's pretty good for self-oscillation if you turn up the resonance and increase the slope parameter. The split parameter will balance the filter cutoff value between the left and the right channel. It's quite handy for getting a nice stereo effect even with mono sources. And as you increase the slope parameter, you're increasing the decibels per octave roll-off of the filters, and that's the same for each of the filter types. So turning it up gives you a more aggressive filter slope. Saturation control will let you boost or cut the input to the filter, and that will be saturated and compensated for at the output. So turning up the level high will actually introduce some distortion, and turning it down will actually help to increase the effect of the resonance. Let's take a look at the 4-operator FM node now. The 4-operator FM node has 12 different algorithms, which you can pick from the pull-down list. In this case, the B and A operator are modulating the carrier waveform, which is D, and unless you turn up the modulation level, you won't hear their effect. But you can also independently control the levels of the A and B operators, which can be useful for modulation purposes. The mix control controls the balance between the carrier wave D and X, which represents whatever combination of operators is shown on the other side of the line on the algorithm. So in this case it's just B. And now we're just going to listen to D only, and we're going to turn up the modulation amount. So now A and B are starting to affect the carrier wave. The feedback control is having an effect on operator A in this particular algorithm. You can see that by the little star that's next to the letter. For this implementation of FM, I've tried to keep things relatively simple by providing a fixed number of ratios that you can pick from. There are actually 128 ratios, and they are pre-selected to provide useful ratios for musical sounds. However, if you want, you can check the ratios times ABC in checkbox, and then what happens then is the inputs to ABC modulation pins can divide down the ratios that are currently set for each of the operators A, B and C. Typically with FM synthesis you want to modulate the modulation depth, and in this implementation I've provided a global modulation control which lets you control the overall level of all of the operators A, B and C. However, you can also individually modulate the levels of A, B and C. Let's take a look now at the 4-operator FM wave sequence. Again, just like the stereo oscillator versus the wave sequence oscillator, this is a sequence of oscillator configurations. This time, for every step, you can select a different algorithm and a different set of ratios and levels, as well as the modulation, feedback, and mix control level. There's also a global modulation boost cut pin that you can still use to modulate the overall modulation depth of all of the table steps. And just like the standard wave sequence oscillator, there's a start position modulation pin, and it's the same system for editing each of the steps. You have a group edit checkbox which lets you edit all of the steps between the start and end position at the same time. As you can see here, we can pick different algorithms for each of the steps, and any of the parameters from the base frequency to the C ratio are editable values for each of the steps. Here we're going to modulate the table position with an LFO. We could use a triangle wave so that the sweeps don't linger at the top and the bottom. In this case, we're going to put the start position to 0, so we may want to use a ramp. And we want to set it to be unipolar so that it's going to go from 0 to 1. In this case, we're ramping down. Well, since we have a unipolar mode now, we can use the triangle wave to go up and down. And just for fun, let's see what this sounds like with some effects. Turning down the low cut value enables more of the low end within the reverb itself. And the same thing with the high cut. The higher you turn it up, the more it cuts the high frequencies out. And if you turn it right down, it enables all the high frequencies within the reverb. Once you're happy with a wave sequence or an FM wave sequence, you can save the table and you can reload the same table into other nodes. So you can see the name was updated on the node, and if we load the same table into another node, we should see each of the steps get restored. There you can see each step is copied from the old wave table, and the name is the same. Let's take a look now at the Pluck String model. The Pluck String model needs to be plucked in order to make a sound, so you need to connect the trigger input to it. So turning up the decay allows the string to fade out more slowly, but in order to hear that decay you still need to make sure that your envelopes are having a longer release time. So in this case we need to turn up the release of ADSR1 so we can hear the full decay of the string. The Pluck String is similar to the other oscillators in that it has a unison mode where it does unison detuned copies of the main oscillator, and you can balance those and you can control the stereo spread with the width parameter. And if you turn the detune control high enough, you'll hear semitone pitch offsets going up to an octave. There's also a mute control which filters the audio within the delay buffer that's used to generate the sound. And we have a distortion level parameter which adds some wave folding distortion to the output of the Pluck String. Let's take a look at the flute model now. Whilst the flute model is designed to be played monophonically, it can be played polyphonically too. It takes quite a bit of tweaking to find the right parameters, and in order to get any sound out of it, first of all you need to increase the breath pressure, either directly or by using a modulation source. Tweaking the reflection settings takes a little bit of experimentation, and the sound can sound quite different depending on where on the keyboard you play it. So here I'm actually playing too low, and if I play some higher keys it's going to actually sound a lot better. Okay, now we're playing in the appropriate keyboard range to trigger the model correctly. And the vibrato rate and vibrato depth controls are hopefully self-explanatory. The breath input could be connected to a physical breath controller. That would be quite good for controlling this model. Alternatively, just use the velocity input from the notes input node, so you'd connect the L output pin. And the slap control controls how smoothly the transition is between two different notes, which are effectively two different pipe configurations. So it sounds more like you're slapping the keys or the fingers on a flute if you have that control turned all the way up. It's quite useful to modulate the noise input with an envelope. Typically when you blow into a flute there'll be a little bit of extra breath noise, and this is a good way to simulate it. And here we're just going to soften a little bit the attack for the noise. And let's use the velocity input to control a little bit the amount of the noise intensity. It might be useful to control the vibrato depth with an envelope too, as typically the vibrato starts off quite low, and as you're playing a note on a flute it would increase in depth. So we use the V input to control the vibrato rate and the D input to control the vibrato depth. Just turn the sustain level down a bit to keep that subtle. And we're going to control the total amount of the input at the mod sources area. And just to complete it, let's add a little bit of reverb or echo, or both. And let's see what that sounds like. Changing the LR ratio changes the delay times between the left and the right channels, which helps to separate the echo effect and make it more spacious. Yeah, maybe a little bit less noise. That's beginning to sound quite nice. And one thing that you'll find with the flute model is it's very hard to get it to be in tune. Once you start tweaking the pipe settings, it might not be perfectly in tune. So the thing to do is to compare it to another tone and fine-tune it so that it's actually in tune with other oscillators in other patches. And that sounds pretty close, so we can get rid of that extra layer. And that's a good starting point. Let's see what happens if we turn the filter on. Probably don't need all that resonance, but good to have a little bit of filter modulation. And modifying the split parameter adds a little bit of stereo separation, and we could add a bit more stereo space by toggling the separation between the left and the right channel. And I'm pretty happy with that patch, so I may as well save it. Always takes a moment to decide which are the best categories to assign, but it's really helpful when searching for patches, especially when you're building a combi patch and you want to find individual layers that might be appropriate. It's really helpful to be able to filter by sound types and sound categories. Let's take a look at the sample player node. The sample player is a relatively simple node, just designed for playing back already edited samples, although it does have a couple of features such as looping and fade in and fade out, as well as being able to select the original note sample pitch, if it's a pitched sample, of course. To hear a sample, you need to trigger it, and to hear the decay of the sample, you need to make sure you have a long enough release time on the amplitude envelope. Here you can see the pitch control. The play speed is a control that's not modulatable, but the pitch is modulatable, as is the fine tune amount. And you can loop the sound. That can be quite handy for background environmental loops, or if you have single cycle waveforms, you can also loop them to use those as an oscillator, and I'll show you that in a little while. So we're just going to increase the release time here so that the sample can play out after I let go of a key. A little bit of reverb never hurts. And here let's take a look at looped waveforms. I'm just going to pick at random some samples from the AKWF library. This is a set of single cycle waveforms that are public domain and free to use. A great resource. You can select the root note for the original sample and it will repitch the sample appropriately for the keyboard. Perhaps not the most exciting sample there. Lots of high frequency content, not much low content. Let's see if we can find something else with a bit more bass to it. Just random selections again. It's more like a square wave sound. We can affect the sample sound slightly by turning up the fade in and the fade out. Anyway, basically you can select any single cycle waveform that you can find and instantly get yourself a new oscillator type. And that will get saved as part of the patch data. So when you share the file, it will get distributed with that file.